This one is the bottom and this one's the top. So it's bottom freezers and top freezers. That's what this talks about. So we're going to go through the solution. So the shape for the top is skewed to the right, whereas this one kind of looks roughly symmetric. So that's how we're going to compare those. Shape. The distribution from the bottom freezers looks skewed to the right, okay? Whereas the top freezers looks like it's roughly symmetric. They also talked about this one being possibly bimodal because it's one mode. That's another good way to say it, okay? And the distribution for top freezers looks roughly symmetric with its main peak centered around 55, okay, right in there. This main peak looks like it's around 70. So center, okay, center. Now, the typical energy cost for the bottom freezers is higher than the typical cost for the top freezers. The center of this one's going to be bigger than this. These are all small values compared to this one, so the center for this one is bigger than the center for this one. That's all you have to say. We have to mention what it is. You have to compare them. The range for the bottom freezers is much greater than the range for the smaller freezers. Okay? Again, I didn't mention any numbers. You don't necessarily have to. You have to use comparison words. Okay? That's that. I gotta add that to my notes. So, stem plots. Okay, oh here it is. Describe the shape. Yeah, it didn't compare though. So now we're gonna go on and talk about stem plots. So again, might be a good time to pause the video, do some practice problems, do some of those homework problems, and then just stop when you get to stem plots. You could probably do, I don't know, probably a handful of problems. I haven't looked at it, but we're going right into stem plots. So these are also called stem and leaf plots. It's a quick picture of the distribution. The stems have all but the final digit, and then the leaf is the final digit. So we do something like this, okay? And what do these values range from? It looks like the smallest ones are, what's that, 13 maybe, and it goes to 50. So I'm gonna go 1, 2, 3, 4, 5. Now, even if I don't have any numbers in the 40s, you can't skip a stem, okay? Now we have to come up with a key, okay? So my key is that 1-1 is gonna stand for an 11. Okay, so now we go through here, and I go through and I say, okay, there's 50, I put a 0 there. Okay, I'd like to put these in order as well, okay? So it is important that we put these in order. So let's look at the 10s. I have a 13, I have 2 13s, I have 3 13s, but I don't have anything smaller than that. So I've got a 13, a 13, and a 13. Notice there's no commas here. We do not put commas in. So I'm going to put a little line through that one, that one, that one. And then I've got a 15. And I don't know that I have any others in that digit. Now let's look at our 2s. Okay, I've got a 23. Another 23. Oh, I got a 22. Oh, look it, I missed the 19. Okay, so, you know, I shouldn't do this right now because this might be someone's note packet, but I am. I'm going to put lines through what we did so I don't make another mistake like that and miss something. Okay, so let's look at our 20s. Okay, I'm going to circle our 20s. So that's a 20, and that's a 20, and that's a 20, and that's a 20, and that's a 20. And then that's another 20. And those are all my 20s, okay? So let's put them in order now. So it looks like my lowest one's a 22. And then I've got 2 23s. And then I've got a 24. And then I've got 2 26s. And I think that takes care of those. So let's put a line through those. Okay, now let's do our 30s. So we've got a 30 and a 31, a 30 and a 31, a 30 and a 31. The next one looks like it's going to be a 34 and then a 38. 34 and a 38. 40s, oh, there is one, a 49. And then 50s, I've got a 0, If it happens twice, you list it twice. A 51 and a 57. Okay? So that's a stem plot. All right? And when you look at that stem plot, sometimes you can describe it. They'll say, describe that. Well, let's look. You could flip it on its side and make it and look and see if it's skewed to the right or it's roughly symmetric or whatever. Okay? So that's how you can look at a stem plot. All right. So here's another one. Okay, here's another one. And it looks like our smallest values are single digits, and it goes up into the 30s. So I'm going to go over here, and I'm going to start with 0, 1, 2, 3. I don't think there's any 40s. Okay, so let's circle all of our single digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like I start off with a 4, 0, 4, okay, and then I go 1, 2, 3 5s, 1, 2, 3 5s, so 5, 5, 5, and then 6, I got a 6 there, let's do the 6, and then I've got 1, 2, 3, 4 7s, 1, 2, 3, 4 7s, let's get rid of those. I got an 8. A lot of those. Okay. Now let's do our ones digit. 1, 2, 3, 4, 5, 6, 7. So 3 10s, 4 10s. One there. 1, 2, 3, 4. 1, 2, 3, 4. Bang, 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 bang. And now we get an 11, a 12, and a 14. 11, 12, 14. Okay, for 20s I have just a 22, and for my 30s I got a 35 and a 38. I got to make a key. 3-5 equals a 35. So sometimes with problems like this, everything's all crammed together, and you can't get a good look at the distribution. So that what they do is they have you do what's called splitting stems, okay? So if I were going to split stems, I might do this, okay? I might do 0, 0, 1, 1, 2, 2, 3, 3. So in this top row, this would represent numbers from 0 to 4. So I'd stop here, 0 to 4, I only have 1. The second one, it's almost like rounding. The second one would be 5 to 9. So I'm going to have 5, 5, 5, 6, 7, 7, 7, 7, and then an 8. Okay, so I split my stems in half. Now for the 10s, this one is all the way from 0 to 4, so it goes 1, 2, 3, 4, these 4, 1, 2, 3, 4, and then 1, 2, 4, 1, 2, 4. And there's nothing after that. There's no 15, 16, 17. So I leave that one. Okay? 20s, 22. 30s, nothing in the first one. The second one's going to be 5 and 8. And then I do 35 and I make it 3-5, I make it 35. Okay? So that's how you split stems. All right, sometimes it can give you a better look at the distribution. And then there's another one that you use what's called a back-to-back stem plot. So that would be if you're looking at two separate variables, okay, and you could put them back to back. So for instance, in this example, they're going to have males and they're going to have females. So the way that I'm going to have you guys set that up, out of paper here, man. All right, where's my paper? I got one. So in order how to set this up, what I'm going to do is I'm going to put the numbers in the middle. So let's look. These go like 150, 160, 170, 180, and so on. So I'm going to make this, I'm going to split the stems, and I'm also going to make a back-to-back stem plot. So I'm going to make this 15, 15, 16, 16, 17, 17, 18, 18. Okay, I'm going to put a little line over here. I'm going to put a line over here. And I'm going to put my females over here, female, and I'm going to put my males over there. Okay? And so when you have, you're always going to have your smaller values start off here and count up, and your smaller values will start here and count this way. So I want you guys to make a back-to-back split stem plot here for this data. So please pause the video and make the two stem plots. You can do them one at a time. You can do males first and then do the females. I wouldn't do them both at the same time. I would go through your data. Males listed first, so do the males first. Okay? Pause your video and give it a shot. All right, so you're back. We're gonna see what this back-to-back stem plot's gonna look like. So I'm actually going, rather than write this out, because it's a little bit tedious, I'm just gonna pull the answer up and you guys can kind of check it out. Here you go. There's the old back-to-back stem plot. Males on this side, females on this side. We can kind of tell. You can you can compare the distributions here. Okay, the range for this is much more spread out for males than it is for females. This is height. Okay, this is height. Okay, so you know the range for male heights is much greater than the range for females' heights. The female heights are bunched or clustered between 152 and what is this? It's probably centimeters or something, right? Centimeters, yeah. It's England, so they use that unit of measure. So 152 to 169, the females are between, and then the males. And you can go on and do some more of that explanation, okay? But I want to get to the end of this unit, so we get into the next thing I'd like you guys to do is the CYU on page 35. Is it check your understanding? These are really good. Check your understandings. That's what they do. They check your understanding of the material. You do a few ideas and you answer some simple questions. So go to page 35, try that check your understanding, and I'll go through the answers shortly. Okay, so we're back. We're back. A boy from his home. Here are your answers. Okay, so the first one said, number 1, use the back-to-back stem plot, which they have in figure 1.15, which is up here, to write a few sentences comparing the distribution. Okay, so it looks like, what happens here? Let's look. Females, much more spread out. Males, a couple outliers for the males. Doesn't look like there's any outliers here. The center is going to probably be greater here. Okay, well, let's look. It says, in general, it appears the females have more pairs of shoes than males. There's no question. My wife has 7 times the amount of shoes that I have, maybe 8 times. Ridiculous. Okay, the median report for the males was 9. The median here is going to be really small, whereas the median for the females is going to be much bigger. Okay, again, comparison words, comparison words. They both have distributions that are skewed to the right. Okay, the females skewed to the right. Don't forget, it's kind of backwards here because the numbers are going backwards. The males have outliers and the females do not. The other answers here, 2, 3, and 4. 2 is B, 3 is B, and 4 is also B. All right, so wrapping it up with histograms. The most important, the most used graph for quantitative data is histograms, okay? So when we talk about these back-to-back stem plots, it doesn't work well for large data sets. If you have a large data set, it's gonna be a real pain. There's no magic number of stems. 5 is a good minimum. If you split stems, make sure there's equal number of possible leaf digits, and rounding data can help. So now we get into histograms. Most common graph of the distribution of a quantitative variable. Our eyes respond to the area of the bars. So when you're making your bars, this is a histogram, okay? Make sure that the distance, the area of your bars, the width of your bars is the same. You don't want this one like this one like this, and then this one like that's no. Okay. What makes it a histogram is its ranges of values. The bars touch in a histogram. Okay? Histograms does not equal bar graphs. Okay? Horizontal axis is marked in the units of measurement for the variable. So whatever you're talking about here, and this is like the counts are over here. Use percent, not counts on vertical axis, when comparing distributions with a different number of observations. Okay? So we have this neat little example here of NBA scoring averages. So what I am going to do is I am going to walk you through how to make a histogram on your calculator. Okay? This is something that you should have looked at. Part of your summer assignment was to look at videos on making histograms. So hopefully that helped, but if not, I'm going to show you everything right here. Okay? So what we have to do is you get your calculator, and I did not add these in yet, so I'm going to do those, add them in with you. So you're going to hit Stat, and then it comes up with this screen here. And you want it, the first one is Edit. That's what we want. So hit Enter. Now, I got to get rid of this stuff. I don't know, this is Lexi's calculator, so one of the data sets she has still in there from last year. So I'm going to clear that and hit Enter and go over here. I'm going to clear that, I'm going to hit Enter, so I've got my data cleared. And again, how do we do that? You get to L1, you hit Clear, and then you hit Enter, and it clears out your whole list. Okay? So now I need to enter all these values into L1. So the first one is whoops, already made a mistake. 101.7, and then hit Enter. And the next one is 99.2. Whoops. Man, I am not doing well. 99.2. I'm used to the older calculators. I don't like these new ones. 95.3. 95.3. Enter. Next one is 97.5. Enter. 102.1. 102.1. Enter. 102. Enter. 106.5. 106.5. Enter. 94, enter, 108.8, 108.8, enter, 102.4, enter. We're 1/3 of the way there, guys. 100.8, enter, 95.7, enter, 101.7, enter, 102.5, enter, 96.5, enter, 97.7, 98.2, 92.4, 100.2, 102.1, 101.5, 102.8, 97.7, 110.2, 98.1, 100, 101.4, 104.1. Sounds like radio stations. Whoops. Made a mistake. Okay, I gotta get back to where I was. Good lesson. 101.4 is the last one I had. Now I gotta do 104.1. 104.1. Okay, and then after that I have 104.2, and I have 96.2. Okay, enter. Now, we have all that information in our calculator. What do I want to do? I want to make a graph. I want to make what's called a statistical plot. So I look on my calculator for stat plot. That's up there. Notice it's in blue, so I gotta hit